Hello everyone. In this video, I will solve problem 12.9. This problem, it has two parts, part A and B. I will do part A in one video, and then I will do part B in a separate one. All right. So what this problem is saying is that it is talking about an MN flip-flop. So it defined a flip-flop as MN flip-flop. And then it says how this flip-flop is working. For example, it says that if m and n is equal to 0, the next state of the flip-flop is 0. Okay, and so on. It talked about all the possibilities of m and n, and then the next states of that of this flip-flop. So part A, it asks for it wants us to complete this table in which we have the present state of the flip-flop, which is Q. So this is the present state. Then we have the next state of the flip-flop, which is Q plus, and M and N. Okay, so basically we have to fill in for M and N because we have all the present and next states. And it says that we can use don't cares whenever it is possible. All right. So we have to fill in this this table, looking at these four statements that we have up here. So I will just number them 1, 2, 3, and 4. Okay, so let's start from the first one. So first one, it says that the present state is 0 and the next state is also 0. So let's see which one of these statements suit these two situation. So in statement number 1, it says that the next state of the flip-flop is 0 if mn is equal to 0. So we can see that it fits here, right? The next state is equal to 0. So wherever we have the next state equal to 0, which is here and here, we know that m and n are both equal to 0. Okay, so we have 0, 0, 0, 0. Okay, so I'm going to divide these different states of the flip-flop so they won't get messy. All right. So the next, let's see if we have any other possibilities that we can fit into Q and Q plus being 0 and 0. So statement number 2, it says that the next state of flip-flop is the same as the present state. So it fits this first situation, right? Because present state is 0, next state is 0. So the next state of the flip-flop is the same as the present state. So in that case, m and n are mn is equal to 0, 1. So we have 0 and 1. Let's see if we have any other statements that fit this situation. So number 3, it says that the next state of flip-flop is the complement of the present state, which is not a case. And the next state of the flip-flop is equal to 1. So this is not a case as well. And in statement number 2, we had that the next state of the flip-flop is the same as present state. So it also includes this state of the flip-flop as well, right? Because Q plus is 1, Q is 1. So the next state is equal to the present state. So Mn will be equal to 0, 1. All right. So let's see. So let's go through statement number 2. So I think we filled both situations that matched this statement, which were the next state was equal to the present state. So let's go to statement number 3. It says that the next state of the flip-flop is the complement of the present state. So wherever we have the next state as the complement of the present state, mn will be equal to 1, 0. Okay, so here we have q equal to 0, q plus equal to 1. So the next state is the complement of the present state, right? So mn will be 1, 0. And also in the third row of this table, we have q equal to 1 and q plus equal to 0, which means that the next state is the complement of the present state. So mn can be also equal to 1, 0. And then the last statement, it says that the next state of the flip-flop is 1. So wherever we have 1 as the next state of the flip-flop, which is here and here, mn should be 1, 1. Okay, so now you see that for each one of the states of the flip-flop, we had two possibilities for mn. And then at the beginning, as I said, the question stated that use don't cares when possible. So what does that mean? For example, in this first row, we see that m is equal to 0 no matter what n is, right? So we can write this as 0x. The second row, m is equal to 1 no matter what n is. Again, we have 1 and x. Then in the third row, you see that n is not changing, so n is always 0 no matter what m is. So m is the don't care here, so we have x 0. And in the fourth row, we have n equal to 1 no matter what m is. So we have x 1. Okay, so we filled this table using these 4 statements that we had for the mn flip-flop. And then the next part of this question is asking us to design a counter using these mn flip-flops. So I will talk about that in the next video. If you have any questions about this one, you can leave it in the comments down below. And thanks for watching.